In this week, we are going to start with the electrical and electromechanical system. Okay? Mechanical system. We will focus on the mainly the components of the electrical resistance, capacitance, or the inductance value, and we will introduce the DC motor model based on the electromechanical features in this lesson. Okay? So the purpose of this section are including the Kirchhoff laws and voltage current rule. Okay, what is the Kirchhoff law? What's your name? Yankı. Yankın. Yarkın. Okay. What is Kirchhoff law? Yarkın. What is Kirchhoff law? You can speak in Turkish. What's the meaning of the Kirchhoff law? Anyone knows that? Hı? Arkadaşlar bağırarak konuşur musunuz ya? It's related to the energy, kinetic or potential energy, but it states that, Yarkın, could you tell me anything about the energy forms of the Kirchhoff law? Yes, but it preserves the total energy. Either we can obtain the current or the voltage for a given system. Okay, it's like the conservation of the energy for a given what? The electrical system. Kirchhoff law states that. Okay, electromechanical system and motion control system. Okay, but we will talk about it in the later sessions. Okay. So firstly we need to write the analogy modeling. What is analogy? Yarkın. Okay. Hacer? Okay. Anyone knows? Hı? Hı? Abi bağırsana ya. Niye sessiz duruyor musun? Bağır gitsin ya. Hala bağırmıyor. Okay, tamam, okay. Before starting the electrical circuits. Sesiniz içinize kaçıyor arkadaşlar. Niye kaçıyor anlamıyorum gerçekten. Sebebini bilen var mı? Dürüst bir şekilde söyleyebilir misiniz? Okay, the analogy means that we have three kinds of energy: mechanical energy, electrical energy, and fluid energy, right? In this term, for example, we always utilize the energy forms, the kinetic and the potential one. And also we can include the losses. For example, in the mechanical system, we have the damper coefficients, right? Okay. And so in the electrical system, we have a loss energy in heats up and heats up due to resistance, right? Okay. And so at each form of these energy forms, we have the input value or the input type to act on this system to move or to feed the energy form. For example, if we have the mechanical energy and then we apply the force value, right? And so this system goes to the right or left or something somewhere, right? In the electrical one, which type of energy is used to activate the system? Just like the force, we input voltage, yes. And so in the fluid system, we can give the system to pressure, yes. Okay. And so if we apply the force to the mechanical system, we can store the energy. In the mechanical system, just remember the spring factor, it's the storing element. What kind of energy or what kind of state or the type is stored? Potential, but based on the what? Force, but no spring, but the spring, just remember the spring formula. Allah kahretmesin sizi gerçekten. Just remember the spring coefficient or the formula. F is equals to K times, yes, and so X is storage, right? And so this is called the across variable. This is called storage variable. Okay? And so if this is the case, which kind of state or the variable is stored in the electrical one? No. No. Huh? No. Capacitor is not a variable. It's a constant. We can store in the electrical energy in the form of current'ı nasıl depolayabilirsiniz arkadaşlar, yani hani charge. Aman tanrım, yani hani. In the fluid system we can store the what? Pressure biz buraya yazdık. Arkadaşlar aman tanrım, yani hani. In the fluid system, this is the mass or volume, okay? But in general form, we have a mass. And so, in the mechanical system, if we apply the force, and so something is related to the d over dt, or the movement part, can be defined with the what? We activate the system, and system generates the what? Change in distance, which is called speed. Yes, velocity. This is equals to dx dt, right? And so in the electrical system, if we apply the voltage, and so we have a flow, yes, current, and so this current is equals to what? The dq over dt, right? And so in fluid system, just like the analogy, m dot is equals to what? dm dt. This is called the true variable. Okay? True. Somewhere to somewhere, or true to somewhere. Okay? This is called the analogy. We can identify or model the system or any mechanical system based on this information. And so, if we have any mechanical system, we can convert this system into the electrical components. This is called the analogy. And so, either we can solve this equation in terms of what, the electrical one or the mechanical one. They give us to what, the same results. Okay? But at the ends, we have always to what? To this form. We have kinetic energy, we have the potential energy, and so always we convert or transfer the energy coming from the kinetic to the potential one, or we can transfer the energy to the kinetic one. Okay? And so always we have a flowing in here or true variable in here. And so this is called to what? The conservation of energy. Okay? We close the system to what? To define the R parameter with respect to the time, which is called the dynamic. Right? If we have this information, conservation of energy, which means that we have a Kirchhoff law. And so, if we take the derivative in time, or with respect to the time, and so our dynamic happens. At every equation related to system dynamics is derived from this theorem. This is the analogy modeling. And so we can either write our system in terms of the what, the electrical one or the mechanical one. Okay? But how we can do that? In order to understand easily this concept, we can write to what, for example, we have this one, K and C and M, right? And so we have also Ft and Xt value in here. How we can write the equation of motion of these terms? Hajar, could you help me? Yes. Just tell me how we can derive this equation. M x dot dot huh? Plus huh? Cx dot plus Kx must be equals to the what? F. Okay. Because we have preserving energy in here, we have loss energy in here related to the damper, and we have also a storage elements in here, just like this one. Okay? And so, how we can write this equation just like it electrical one? How we can convert it? First of all, if we have the force value in here, just like this one, C dot X, right? Fc. This is the loss energy. What is the analogy in electrical system? F in the electric, yes, voltage, and so X dot X dot is equals to Q dot, which means that current. And so, what is the values of this term? Yes, R. See? If we are using the resistance, and so we can model the what? The C times X dot in the mechanical one, right? And so, F M is equals to what? M X dot dot. And so, Fm is equals to voltage. X dot dot. What is X dot dot? X is in the charge. And so, the derivative of charge equals to the what, Yarkın? Current. And so, derivative of the current should be given in here times which constant should be applied in here? Resistance'ı kullandık zaten yani. Allah'ım ya. He? No. Yes, inductance. Okay? And so, Fk, K times X, right? So, this is the voltage. And so, what is the values of this X in the electrical one? Charge. And so, which constant should be applied in here? Capacitance, right? This. Huh? It's okay? Is it true? Is it true? Hajar, this is true? Okay, this is wrong because this is 1 divided by C. Okay? And so this is the analog in here. Okay? So we can use this value in order to what? In order to build the R, Vt. These are the force value. And so we have resistance in here, we have inductance in here, and we have also a capacitance values in here, just like this one. And so in this form, this R is equals to the C, right? This is the mechanical damper coefficients, this is the M, and this is the equals to what? The 1 divided by K. And so either I can solve this equation in the electrical domain or in the mechanical domain. Okay? This is identical. See, this Vt is equals to the what? L times d square Q over d square, and so 1 divided by C Q plus R dQ dt. These equations are identical or analog. Okay? Either I can use this electrical formula or the another one. Okay? So this is called the analogy. Do you understand right now? What is analogy? We can convert any mechanical system into the what? Into the electrical one or the hydraulic one. And so we can easily solve or apply the another rules based on the what? The electrical domain. Okay? We can apply the Kirchhoff law to solve to what? The mass spring damper system based on this information. İlayda. Okay? And so if this is the case, then we will continue with the what? With this form, like in mechanical energy form. We get Ka, this is the kinetic energy, this is the potential energy, this is the loss energy. Okay? And so in the mechanical system, what is kinetic energy? Just tell me. Huh? mv square, yes. mx dot square. What is the potential energy? Huh? Huh? No? Yes. What is the loss energy? Huh? C x dot, but this is the force. What is the energy form of this equation? 1 divided by 2 C x dot square, right? And so in the electrical form, what is the kinetic energy? İlayda. Abi denklemi koysanız yerine. I square. What is the potential one? Yes. What's the loss energy? Yes. That's all. It's so simple. Just you can use this form in order to what? In order to solve your equations. In terms of what? In the electrical form or the mechanical form. Because sometimes in the mechanical form, our equation cannot be solved easily. Or you can easily see the solution. And so, if this is the case, Yarkın, and then we can convert the whole equation into the electrical one. In terms of the what? Either the energy form or the voltage form. Right? And so we can easily solve this equation based on this information. That's all. Okay? Okay? Abla senin ismin ne? Ha? Zuzan. Okay. And so if this is the case, and then just remember the previous lesson. We have talked about the 623 state variable form, right? And so in this case, or in this lesson, we will focus on the solution of the circuit, state variable models of the circuit. Okay? And so first of all, consider the problem. Just like this one. It's the VT, right? And so we have R, we have inductance, and we have capacitance. Okay? See. And so in this system, just tell me, what is the analogy of this term in terms of the what? The mechanical one. How we can represent this circuit in the what? In the mechanical systems. Yes, thank you, Yarkın. Okay, that's all. That's simple. And so, just remember the Kirchhoff law. How we can apply the Kirchhoff law in this circuit? Just could you help me to write? I, okay. R times I Huh? No. We can call it the VC, right? And so we can solve it because the VC should be equal to the what if we have the every current element in here, and so in terms of the current, I dt times 1 divided by C, right? These are the what? The voltage, VC value, right? Or we can write it d VC over dt is equals to what? 1 divided by C I, right? We have two formula in here. And so just remember how we can write the state variable form in here. In order to solve the state variable form, which variable must be utilized in here? Our first equation is that this one, and the other one this one. Just remember the state variable form. Anyone?
Current should be utilized.
Huh?
Current value.
Yes, current, because
It is the variable.
it's variable, or it depends on the time, right? Di divided by dt. It's in the form of the first order representation, not the R, not the L, right? And so we should write to what? Di dt. And also we need to write, check the equation, we need to write another state. No, I is written in here, and so just look this equation. Huh? VT or VC? Why?
It also depends on I.
Huh? No, it's not related to this. dVC divided by dt. And so how we can write this equation? Di divided by dt. What's your name?
Mohammed.
Mohammed, just help me.
Let's call it Z1.
No, so just remember that di divided by dt. And so we reorganize this equation in here. Firstly, I times, we have minus RL, right? And minus CL, I'm sorry, 1 divided by L times VC plus 1 divided by L V, right? This is the reorganization of the what? The first equation. Just take the what? The di divided by dt in here. Just simple math. Anyone can do that. And so what is this equation here? Huh? I times 1 divided by C, right? Firstly, in order to write to what? To state variable form, you should collect the whole equations just like this one. We should write the time dependent parameter di divided by dt at the left hand side, dvc divided by dt at the left hand side, and so we can express the every equation just like this one. And so we can convert this form into the state variable form. Okay? Okay. And so how we can write this equation? Just like the Mohammed said. What is the Z1, Mohammed? Mustafa? Mohammed? Which one? Z1. Yes. Z1 is equals to? Huh? Z2?
Di over dt.
No. Z2? Huh? We see. Yes. We see. And so, if this is the case, we should write the what? Z1 dot, Z2 dot, which is equals to the what? We have this form Z1, Z2 plus some input value, VT. Remember that we have the Z dot is equals to AZ plus B V, right? These are the form. And so, how we can write the A matrix? What is the dimension of this matrix, A matrix? Huh? 2 by 2, yes. What is the dimension of the B matrices? Zozan? Zozan mıydı? Zozan. Okay. What's the dimension of the B matrix? Yes, this one. Yes. So, just help me how we can write this empty space. Okay.
So in the first place, we have for the I1, we got the left part, which is minus R divided by
Thank you. And second one?
it is 1 divided by minus 1 divided by
Because the Z2 is multiplied in here. And so what is the term of this value?
it's supposed to be the coefficient that side of the dt, which is 1 over n.
And so in the second place, Z2,
1 over c is 0.
yes. And so In the last place? Thank you. This is the what? This is the state space representation form of this electrical circuit. Okay? Just see that we convert the VC value as a state in here. Normally, we should solve it in the integral form. But if we are using the state space form, Zozan, and so this is just like the matrix elements. And so we can instantly solve this equation easily. See? This is the advantage of utilization of the what? State space. Otherwise, we should solve the integral formulation in here at each case. But in the state space form, we don't need to do that. We can just solve this equation based on this information. Okay? Okay, so there is another important parameter, impedance. What is the impedance? Huh? AC resistance, which means that the impede means resist, right? For current, right? But what's the difference between the impedance and the normal resistance? Be loud, be loud, be loud.
As I remember,
Huh.
you know that the difference between the DC and the AC,
Huh.
it gets to wave. It's from the wave.
Yes. Normally, the normal resistance does not change based on the frequency values of the change in the voltage value. But there are some coefficients or the important parameters in the electrical system, like capacitance or the inductance value. And so these parameters, system parameters, are changed based on the what? The input voltage, right? Which means that we have the capacitance value, right? We have the resistor, or we have inductance value. Just remember that V equals to I times R, right? It's not dependent on the what? The frequency or the input frequency, right? If we apply the AC voltage, and so this resistance cannot be changed in here. But in order to show this, we should utilize what? The S domain, Laplace transform, right? But why? Why do we need to use the Laplace transform? Yes. In order to analyze the frequency characteristics, and so we should apply the what? Laplace transform. Otherwise, we cannot know anything about that. Or, in the capacitance, just like Zozan said, 1 divided by C times integral I dt. How we can apply the Laplace transform? What is the results? Ws is equals to no, 1 divided by S times Is. Okay? And so how about the inductance value? Vt is equals to what? L di dt. How we can write? Vs is equals to L times S times Is. Right? Okay. And so the main utilization purpose of this term, it is enables us to analyze the system based on frequency response of it. Right? That's the main conclusion about that. So, in the example, let's back into the watt, MCK, LRC equations. Okay? Just remember that the Vt is equals to what? The L times di divided by dt plus R times I plus 1 divided by C times I dt, right? In the S domain, we have the Vs, right? And so, as well as the Is. And just help me, how we can collect this form? How should I write? Huh? SL, right? L times S plus R plus 1 divided by C times, yes, 1 divided by S. See? And so, the impedance Zs can be shown in this equation, just like this one. LCS square plus RCS plus 1 divided by C times S. This is equals to the what? Zs is equals to Ws divided by Is, right? See? This is called impedance, or the impedance in Turkish. So, what is the definition of the impedance? Impedance means that the ratio, or for a given unit current, how we can apply the voltage value in the system, or in the system representation, we can write that the Zs over minus 1 Cs divided by LCS square plus RCS plus 1. This is the R transfer function, right? For a given input voltage, how we can employ the current for a given system, right? If we apply the 1 unit voltage, how we can collect the current in this system? And so, just like the resistor in here, we can build this form as a collective resistance, but with the basis on the what? The frequency domain, which is called the impedance value, right? We can analyze also the frequency response characteristics, or the effect on the frequency characteristics on the what? On the system as a single resistance one, right? Just like this one. And so we can also write to what? To this one. Ft is equals to mx dot dot plus cx dot plus kx, right? And so Fs is equals to what? The xs times ms square plus cs plus k, right? This is the Laplace transformation of these terms, right? And so, the xs is a storage element. We should convert these elements into the what? Into the velocity one in here. How we can do that? Ft is equals to what? The m vt plus c v plus k times v dt, right? This is the representation of the what? The first equation in the velocity one. And so, what is the Laplace transformation of these terms? Fs is equals to what? Ms vs plus c Vs plus K Vs times 1 divided by S, right? And so if this is the case, just like in the previous example, we can write the Fs divided by Vs in here. How we can do that? How we can do that? Huh? See, if we have this S value, ms square plus cs plus k divided by s, right? These are the formulation. Abi yani basit matematik yapıyorum şu an. Sade giderleri sola alıyorum şu an. Farkındasınız değil mi? Şimdi bakın. These are the equation. And so, what is the impedance in here? Impedance is equals to what? To this one. Right? This is the impedance value. What is the transfer function in here? Yes. Vs Fs is equals to the what? S ms square plus cs plus k. And so the inverse impedance is equals to the what? The transfer function or the conductance value of this term, guys. Okay? Which means that the impedance is equals to the what? The inverse form of the transfer function or the inverse of the conductance value, but with one basic difference, which is the what? It's dependent on the what? The frequency. Okay? Okay? Any question? If there is no question, and so we'll take a break after